Good morning, everyone. This is Mike coming back at you with another video on Intro to Algebra. In the previous video, we talked about variables, algebraic expressions, and algebraic equations. In this video, we are going to talk about sets of numbers, especially the set of real numbers and the real number line. So what is a set? As a recap, a set of numbers is a collection of numbers where we separate each of them by commas, and we enclose all the numbers that are separated by commas inside of set brackets or squiggly brackets or braces, what we saw back from section 1.1. So now we're going to look at some basic sets that we're going to talk about in this course and what their names are. The set of numbers beginning with 1 and then going up by 1. So 1, 2, 3, 4, 5, 6, 7, 8, continuing so on and so forth. It's called the set of natural numbers or the set of counting numbers. So 1, 2, 3, 4, 5, so on, natural numbers. The next set is almost exactly the same thing, but now we include the number 0. So it's 0, 1, 2, 3, 4, 5, 6, so on and so forth. This is the set of whole numbers. So there is a little bit of a difference between the natural numbers and the whole numbers. Whole numbers contains 0, natural numbers does not. Now we have the set of integers, which is 0, 1, 2, 3, 4, 5, so on and so forth, but also has the negative numbers, -1, -2, -3, -4, so on and so forth going down. That is the set of integers there. Before we get to the next sort of important set that I want to talk about, I want to talk about a particular notation that's called set builder notation. We can use the following symbols to represent a set of numbers. Now we have the set brackets. We have our variable or a letter to stand for the guys in the set. We have a big vertical bar, and then we have some words here that follow that big vertical bar. The two set brackets in this context, the English sort of translation of that is the set of all. The letter that we have here is sort of translates to elements X. The big vertical bar here stands for such that, and then what follows here is sort of some property that these elements have to satisfy, and they sort of logically, the words here that are written sort of logically complete the sentence. So how we would read this entire thing is the set of all elements X such that X is greater than 0 in this particular case because that was the property that we had. It could be the set of all elements X such that X is less than 10, say. But now some of you may have seen this word element or elements and thought, okay, what the heck does that mean? An element of a set is simply a number that's in that set. Going back to our samples here, the number 1 is an element of the set of integers because the number 1 is inside this set. Likewise, the number 0 is an element of the set of whole numbers because it's inside of that set. So here's a couple problems, some practice switching between English and set builder notation. The set of all elements X such that X plus 2 is equal to 5. I'm going to write this in set builder notation. So comparing this to what we had right here and how that reads, we're going to have those set brackets or those braces or those squiggly brackets happening there. So we have inside of there, we have the set of all elements x. So that tells us that the letter that we have to use is x. We have the such that symbol. And then what follows after the word such that is everything that goes to the right of that big vertical bar. So x plus 2 is equal to 5. So there we go. That's how we write this sentence, this statement, in set builder notation. All right, let's try going the opposite way now. Let's write this thing that's in set builder notation, and let's write it as a sentence. Well, again, we see all of our pieces. We see the two set brackets. That means the set of all. We have the x here, so that means elements x. We see our big vertical bar there, so we know that that means such that. And then we have what follows after our big vertical bar, completing the sentence. X is positive, and less than 10. So there we go. Really easy, really straightforward to switch between a sentence and something we can write in set builder notation. So now that we know set builder notation, we can now talk about the set of rational numbers, aka fractions. So the set of rational numbers is really the set of all numbers, x, such that x is a quotient of integers with the denominator, aka the bottom, not being 0. So the set of all numbers, as we just said, the set of all numbers that can be written as a quotient of integers and the bottom is not 0. Something else that typically goes along with this is that we say that the two numbers involved in our fraction are in what we call lowest terms. And by that we mean there's no common factors between the top and the bottom of our fraction. But now, what types of numbers are rational numbers? Well, all of the integers are rational numbers. All mixed numbers, something like a whole number and then a fraction that's next to it, that's a rational number. And then all decimals that are terminating, as in they stop after a finite number of decimal places, like 2 or 3 or 5, or even 10, or an infinite decimal where the pattern is repeating. These are all examples of rational numbers. And I have more examples down here. -4, that's rational. 8 2/3, that's rational. -11/2, 4.2, there's a finite decimal, and then 0.33333333333. That pattern of 3s that's constantly repeating, that indicates that this is a rational number. And we can represent any of these numbers on the real number line. Pardon me. This is probably familiar to most, if not all of us. Big, long horizontal line, arrows on both ends, and tick marks to represent the integers on that line, and we can plot certain numbers like 1/2. We can go 2 3/4. We can go -1/3. And we can plot any other numbers that we wish on here. Just put the tick mark and then put the number there as well. Now, there's another set of numbers that doesn't really have anything in common with any of the other numbers that we had talked about up until this point. And they're called the set of irrational numbers. But what is an irrational number? An irrational number is a non-rational number that's represented by a point on a number line. Okay, well, that's a weird definition because it doesn't really add much clarity as to how do we figure out what numbers are not rational. Here's how you figure out. The decimal form of an irrational neither terminates, so it doesn't end, it's a decimal that keeps on going, nor does it repeat. That is to say, there's no repeating pattern that the numbers after the decimal point go. So here's a sample. 1.21568032597. There's no pattern happening here. We're not going, say, like 345, 345, 345. It's just random numbers that are following each other, and they're not spread out in any specific kind of pattern. So there's an actual decimal that is not rational. We see the square root symbol here. In case you haven't seen that before for some reason, we'll be seeing that later on a lot more. But the square root of 5, that is also a number that is not rational. And it's when we combine the set of rational numbers and the set of irrational numbers is that we get the granddaddy of all sets. We finally get that big set. We get the set of real numbers. The set of real numbers is a set of all elements or all numbers x such that x is either a rational number or it's an irrational number. So that's the big set. That's the main set that we're going to be working with inside of this course. So just by looking at the real number line, we can use that to figure out whether one number is greater than or less than some other value. Pardon me. We say that A is going to be less than B, and we write it as such if A is to the left of B on the real number line. We say that A is greater than B, and write it as such if A is to the right of B on the real number line. So again, going back to our real number line here that we had, if I just plot one more number here, clearly we can see that 2 3/4 is going to be greater than 1/2 because this guy is to the right of the 1/2 on the real number line. Here we see that -1/2 is less than -1/3 because -1/2 is to the left of -1/3 on this real number line. And that's something that perhaps if you just saw it on paper, you might think, no, that's not the case, because you think 1/2, 1/3, oh, okay, the 1/2 is greater than 1/3, so why are we saying that it's less than? Well, it's because they are negatives. And by looking at this real number line, it's easier to see, okay, that's why. This number is farther to the right than that guy, so this number is greater. Just helpful hint, the arrowhead or the arrow is always going to point to the smaller number. So if you have two numbers and you know that one is smaller, you have the arrowhead point to the smaller number. A key property to keep in mind or to recall about numbers that are negative and negative signs. The double negative, which means that if you do minus some number, these minuses multiply out to a plus. So if you see a minus times a minus, minus times minus, the minuses combine and they form a plus. So if I have minus a negative 5, that's the same thing as positive 5. If I have minus a negative 0.47, that's just a positive 0.47. Next key word, key phrase, the absolute value. For any real number, call it x, the absolute value of x, and we denote it by x inside of two vertical bars. So this right here is saying the absolute value of x. This is the distance that x is from 0 on the real number line. Now, because we're talking distance, and we never have a distance that's negative, the distance, aka the absolute value, is always going to be a quantity that is either equal to 0 or it's going to be something that's positive. So that's very important to keep in mind. The absolute value of a number is something that's always equal to 0 or is positive. If a number x is positive or equal to 0, then the absolute value is just going to be the number that it was. If x is a negative number, then the absolute value of x is going to be the negative of your x value. It's going to be minus x, and that's going to make it positive. As an equation, we write it as such. Now, don't get too hung up on the notation of how this is written. Just know that guy right there, which is if your number is equal to 0 or positive, the absolute value is just that x value. If your x value is negative, the absolute value is the negative of your x value. And here are some samples to just wrap up this video. The absolute value of 12, 12 is 12 away from 12, so that is 12. Negative 5/7, again, the absolute value of a negative number is the negative of that number. So minus the minus 5/7 by our double negative is equal to 5/7. The absolute value of 0, well, 0 is 0 distance from 0. So that's why we say that the absolute value of 0 is 0. And then 1.724, absolute value of that guy, again, it's a positive number. So absolute value of a positive number is just that same number. So that's 1.724. So guys, this concludes our video on some of the basic sets. Natural numbers, whole numbers, integers, rationals, irrationals, and reals, as well as some other key properties, the absolute value, real number lines, things like that we're going to be seeing and using throughout this course. If you have any questions or comments, please be sure to reach out to me, guys. Send me an email, stop into my office, give me a phone call, whatever you have to do. Otherwise, until the next video, take it easy, guys.